This is Euclid Book 3, proposition number 35, part 2. And in this video, I know I'm kind of moving around here a little bit. I do it this way. Alright, do you remember back in Euclid Book 2 where we were taking sides of a rectangle and making a full rectangle out of it? That's basically what we're going to do here, and I'll show you what I mean, okay? First of all, Euclid wants you to draw a circle with two lines. The circle will be A, B, C, D. As you can see, we drew the circle through point A, through point B, through point C, and through point D. And then we drew two lines. And the first one was from A to C. The second one was from B to D. And they intersect at point E. And then Euclid wants you to find the center of this circle. Okay, you use all kinds of methods to find the center of the circle, which in this case ends up being F. Alright, then Euclid wants you to draw a couple of lines. He wants you to draw a line from F to G and another one from F to H. And these two lines from F to G and from F to H have to be perpendicular. F to G has to be perpendicular to AC. Okay, so FG is perpendicular to AC. FH over here is perpendicular to BD. Okay? FH is perpendicular to BD. Now, line GF, which this is FG right here, okay, it bisects AC. Alright. And we know this by Euclid Book 3, proposition number 3. And we also know that line AG and GC are exactly the same size. Okay? Because if a line bisects another line, it makes the two new lines equal in size. Alright. Now, since AC, this is AC right here, since it has been cut into equal parts by FG, and it has been cut into unequal parts at point E, okay, then we can say that the rectangle that would be formed if we were to use sides AE and EC. Well, here's AE and EC. If we were to use these two sides and made two more sides to it, we'd form a rectangle. Okay, if we duplicated this side and we duplicated this side and we made a rectangle out of it, we'd have a rectangle. Okay, so the rectangle contained by AE and EC plus the square of EG. Now, do you remember back in Euclid Book 2 when we actually drew a square and each of the four sides was equal to a particular line? Well, the line here is EG, so we have to first find out where EG is. It's from here to here, okay? So let's say that this was one side, EG here was one side of a four-sided square. So every one of the four sides was equal in length to EG, okay? So now we have a rectangle. It has two lengths in the sides of AE and two lengths in the sides of EC. So that's our rectangle, okay? And then we also have a square in which one of the four sides is EG, okay? The area of that rectangle plus that square would be equal to the square of GC. Now, where is GC? Here's G, here's C. This would be one side of a four-sided square. So the area of the rectangle, which was formed by AEEC, plus the square of EG, all that area together would equal the area of GC. Okay, the square of GC. And we can say this by Euclid Book 2, proposition number 5. Alright, so now we're going to say that the rectangle formed by AE and EC, once again, if AE was two sides of a rectangle and EC was two sides, you put them all four sides together, formed a rectangle out of it. Okay, so you have the rectangle of AE and EC plus the square of GE. Where is GE? Right here. This is side one of a four-sided square. So the area of the rectangle plus the area of the square plus the area of the square called GF. Well, here's GF here. If we were to make a square, we would have four sides that would be equal in size to GF, and the area inside of there would be added to the area of the square GE plus the area of the rectangle formed by AE and EC. Alright, if you have all those areas added together, you would get the same area as GC plus GF. Now, GC is here. Okay, so you'd form a four-sided square using side GC. And GF is here, right here. So you'd have a four-sided square here. Okay? Now, hopefully that has not confused you so far, because we've got to go one more time in video to continue this proof. I will tell you more in the next video, so stay tuned.